Right. So 16.5, again I will repeat, it is not the important code book, and almost 50% of the questions we have attended yesterday. See, this question bank only online, same. What is given to you in printout? This is the same question only. So I will use online, but both are same only. So first one, what is the maximum pressure class 400 flange metal A 180 FAT can be used as to 450 degree Fahrenheit? I think yesterday you attended this question. What is the answer? 875 PSI. Yesterday we attended during the class. Next question, what is the maximum recommended? I think the answer is 800 degree Fahrenheit. 800, because it is same. It is not recommended more than 800. You see the A551 states there was a note 1. So more than 800, it is not recommended. Third question, which of the following class should be used for 182 7? This also we attended. Class 400. Okay. You can follow this question, same only this. Next one, for any temperature below minus 10, 20 degree Fahrenheit, the flange rating shall be. Okay, so where you have to find the answer, you can see here, your code book. You can see here, for any temperature rating below minus, the rating shall be no greater than rating shown for minus 20 degree Fahrenheit. That is the answer. So answer is in page number 2. We highlighted it yesterday. 2.4 rating temperature. So any rating means you have to check the heading. So any rating, so this is not greater than minus 20 degree Fahrenheit. So the answer is less than minus 20 degree. So not greater than means less than. Okay. Okay. Next one. Class 600 flange may develop leakage if it is used above 750 degree Fahrenheit. Where is the answer? It is here. You can see here. And above for other, so class 150 above 400 and other class above 750. Okay. Next question. Which of the hydro test pressure 180 to F34 gross 400 joints? So answer is, yesterday we worked out 1450 PSI. This will be worked out. You remember? Okay. Next one. What is the maximum bore diameter allowed for class 600 NPS 4 flange? I told you no need to attend this one. Bore diameter, because this question is not asked in the exam. Suppose if you are really interested, no, I want to know this. So I will work it out. This is the formula you have to use. But don't worry, this formula is never asked in the exam. AH1 minus COPC divided 50,000. Try this. I will tell how to do it. Try this, no problem. This is the formula. B max is equal to maximum bore diameter. So what is the formula? AH1 minus COPC divided by 50,000. Now, what is AH? Tabulated height of diameter. So we have to refer, yesterday we remember we check the table, flanges and flange fitting each class. That table you have to find AH. See, CO is 1. You can see CO 14.5 and PC is expressed in bar units. So CO is 1. PC is the sealing pressure. You remember sealing pressure, there was a table A2, appendix A2 here. Sealing pressure we have to find from it is given here. A2 we have to refer it at 100 degree Fahrenheit, work it out. See, again I will write B max is equal to B max is equal to AH 1 minus CO PC divided by 50,000. CO, it is 1. Only you have to find PC 50,000 1 minus. I will show you the question. Try this. I will give some time. Try this question. So we are asking class 600 NPS 4 well neck flange. So you have to go to the class 600 table. Class 600 flange table. You have to find AH. Class 600 தானங்க இருக்கு. Class 600. எதுங்க? Where is I? See, CO is equal to, it is given here. Weight 14.5 when PC expressed in the bar, 1 when expressed in the PSA. So this is CO is equal to 1. You have to PC, you have to refer A2 table. AH, you have to go to this particular table. Try this question. It is not important. See, we have to find the AH from that class 600 flange table. What is the AH? 14. So what is PC? 1000. So 1500 divided by 50,000. Then 1 minus, see, we have to work it like this. So if you write in the formula, so AH is equal to 14. 14 1 minus 1500 divided by 50,000. So if you work it on 1500 divided by 50,000, 0.03 minus 1, it is 0.97. So the 14 multiplied by 0.97. So 14 multiplied by 0.97, it is 13.58. This is the answer. So the answer is 13.58. This question they never ask in the exam. That's why I skipped yesterday. Even if you don't understand, leave it. It is not serious. Okay, but because it is in the question bank, after 1 week, you should not call me, sir. There is a question bank. I couldn't attend it. So I explained this. AH, see, what is A? AH, what is given? Tabulated hub diameter beginning chamfer. AH, you have to refer the table, the 600 flange. See, if you go to this from here, this is for the flange fittings. So flanges you have to go. Where is 600 flange? This is 900 flange. So this is the 600 flange. You can see the AH will be. So this you can find AH here. Diameter of the hub AH. So what is the diameter we have given? 14 inch. So 14 we have to see what is the AH. Next page. 14 AH is the 14. That's all. Page number 170. It is in page number 170. So we have to find the table. That's all. Otherwise, these questions are not very difficult. So the next question. This is the AH we have to find, page number 170. So the next question, the length through hub NPS 10 straight hub welding neck flange shall be. So either B and C. So for how it is either B and C, if you go to the code, you can see, say length through hub shall be 9 inch for NPS 4 and smaller, larger than other length may be furnished by agreement between the end user and the manufacturer. So others are also allowed. So it can be either 9 inch, 12, it is a NPS 10 means 12 inches or any length agreed between the manufacturer. B and C. The next question, A351 grade CK20 belong to material group number. So we have to refer the table and find it. Which material group it is belong? 2 point. So we have to refer this table 2.12. So it is the A315 grade CK20, it is here. Okay. The answer is 2.12. Next one, plate material shall be used only for, I told you, blind flange only it is allowed. Blind flange or some reducing flange only allowed. Other flanges it is not allowed. Next one, which of the following is considered a high strength bolting? So if you check, everything will be in the list. So answer is all of the above. Next one, for class 600 flange and which of the following bolts shall not be used? So yesterday we worked out 193 grade B80. Answer was 193 because it is a low yield strength bolting. Next one, which of the following gasket should be used for 193 B80A bolting? So first you have to find out which is this one. So if you go to this bolting 193 B80A, 193 B80A will come here. It is a low strength. Okay. So if you go to the code book, you can see 193 low strength bolting. You can see here gasket for low strength bolting. You have to refer this paragraph. Bolting low strength table used. Table B1 group 1A are recommended. Only group 1A we have to use. So please go to the appendix B and find out which of the following gasket is group 1A. So answer is elasto without the fabric gasket. That is the answer. Okay, right. So we have to refer the appendix B. Which page number? 199. Check 199 and find it. Okay. Next one. Is it okay? No. Next question. What should be the raised face thickness for class 600? Very important question. I told you this is a regular. I told you so class 150, 300, it is 0.06. Other classes 0.25. If you are not familiar with the inch, convert it to mm. How will convert it to mm? Multiply by 25, 25.4 exactly. What is the maximum radial projection allowed for that is deeper than serration? We worked yesterday. Answer is 0.06 inch. So the table you have to refer, yesterday we did this during the class. The next one, what should be the minimum thread length of the class 150 NPS3 flange? Threaded. Okay, this is also not important question. So how to find out or where to find out? You can see here, threaded flange. You have to go to the class 150. This is correction tapping. So class 150 flange, we have to go. Okay. Outlet cup normal pipe sets, recording flanges, pipe size. One. No, what is the question? What should be the minimum thread length of a threaded class 150 NPS3 flange? Okay, class 150 threaded. Reducing threaded slip-on flange class 150. No, 150, nothing is there. Thread length of the threaded class 1. Class. Something missing. Thread length. Right. Nominal pipe size 3 inch. Reducing outer occur nominal pipe size. Reducing. One point. Page number. Yes, yes. Okay, minimum threaded. Okay. 3 is 1.19. It is given here. Okay, right. He's right. So 1.19 inch. Okay, next question. What should be the thread length of connection tapping NPS2? So connection tapping we have to refer here. The front, it is not here. Connection tapping will be here. This is the connection tapping. So you can see the connection tapping here. Page number. Again, these are not important. Whatever important we covered yesterday. Page number 22. So what is the question? What will be the thread length of NPS2? So what is the NPS2 connection tapping thread length? 19.0.76 inch. Bracket it is given in inches. So answer is 0.76 inch. Next question, which of the following shall be used for the hydro test of flange fittings? Water with the corrosion inhibitor you can use, kerosene also you can use, or plain water, any of the above. So it is given here. So you can see here the pressure, the shell pressure test, which may contain using water, which may contain corrosion inhibitor, other suitable kerosene also we can use it. Now question number 19. What should be the stud board length for class 900 ring joint flange? I think yesterday we did it 11 inch. Lastly we did it 11 inch. So we have to go to the class 900 flange. table. So where it is this class 900 flange table? One. Okay. 1500. You can see here. Class 900. This is the one. So the question is NPS 14, and this is R for the ring joint. So NPS 14 ring joint. You can see the length is 11 inches. Then last question, what should be the pitch diameter for NPS 6 ring joint flash face with the groove number R45? Okay. So where you have to check, I will say test. We have to say ring joint, there is a table here. It will be after this ring joint table. I will tell you the table. Ring joint table is here. See here, ring joint table. Page number 116, 118. So please find the answer for me. The answer is 8.312. Okay, so it is asking NPS 6. Okay, ring joint with the groove number R45. So groove number R45 up to 6. So R45 here, pitch diameter is 8.31. That's all. 16.5. Okay. So no need to again refer 16.5. I am telling 578, 16.5. That's all. Exam point of view, that's all. If you able to search, little bit take little time, but if you are not confident to do it at the last, if you think it will take a lot of time to search, you can see the index. First thing what you have to do it, we have to go to the index, how it is arranged. When you have time, go through the index, how it is arranged, you can see here. So somebody asked if there is a chart morning, how this is arranged. So this is the one. First, it will start with the code book. It will start with the list of material specification. Then the table will come, pressure temperature rating table. Once the pressure temperature rating is completed, I told you have to refer only the C table. So it is, you can see up to, it will go up to here, 312, 19, 2.3.19 C is the last table in page number 100. After that, permissible imperfection flange finish rate, it is appendix 3C, page number 102, that is important. Any radial notch, what should be the maximum? That is the appendix 3. We are always referring the C table. Then 4, dimension of facing other than ring joint not important. 5, ring joint facings. That is last question we attended. That is also actually not important. Reducing threaded slip-on flanges not important. Then it will start from class 150, the flange table. 150, then 300. See, class 150 flange and flange fitting continuously. 300 flange and flange fitting. Next page will be flange fitting. Flange fitting. 400 will have only flanges. 600 actually flanges. 900 flanges. Then 1500, 2500 flange fitting for 400, 600, 900, which will be here in appendix E. Then appendix A1, there is a ceiling pressure. That's all tables. So I told you that generally there may be only 2 questions asked from this one. So you should know, just click there. I told all HTML link will work. It will directly go to the stage. Now, so we completed 16.5. Now I will go to the on half an hour class 570 calculation basis. Okay. First, I will close all these things. I will use a whiteboard, then we can share it. Right. I will use a whiteboard so that you can please understand this basics. Very, very important for exam point of view. If you don't understand, please ask again. Right. See, you remember I told you how the piping thickness is calculated, process piping. So first we will use a design formula. What is the B31.3 formula? T is equal to PD divided by 2 SEW plus PY. No need to remember this formula. It is an open book. They will calculate the thickness. If structural minimum thickness is there, then we will compare. Whichever is the higher thickness, we will take it. From that only correction allowance will be added. If there is you want to correct, who will decide the correction allowance? It will be decided by the owner. What is the formula for correction allowance? Yesterday I wrote correction rate multiplied by the service life. If you know that correction allowance. So they will calculate, add the correction allowance. That thickness is called as a nominal thickness or ordered thickness. Okay. See, even if you calculate it, exact thickness you will not get because pipes are in schedule or standard only. Whichever is the next higher one, they will choose it. Whichever the schedule 40, 60, whichever the next higher one, they will choose it. Now, once the pipe is installed, for example, this nominal thickness only used for impact test requirements, preheating, PWST, radiography acceptance, whatever we have seen in B31.3, all we are using is nominal thickness only because actual pipe only we are doing all this testing. It is not the design thickness. We never use for our all NDT, PWST, preheating, impact test design thickness. We are using the nominal thickness. For example, a nominal thickness of the pipe. Thickness of pipe, say, I will put a value 0.5 inch. This is a nominal pipe. Now it is starting service. Once it started service, then it will be a 570 scope. Before service, it is a B31.3 scope. Once service started, it is the scope of 570. So what the 570 inspector should do, practically go and measure the thickness of the pipe. You should not follow the drawing because drawing will have tolerance. Seamless pipe, what is the tolerance? 12.5% tolerance allowed. So you should not follow that. Physically, he will measure the pipe thickness. So for example, the pipe thickness is 0.5 inch. This thickness is called in 570 language T initial. This thickness is called as a T initial. T initial nominal thickness both are same because just a starting surface. Suppose same location in a pipe, particular location we are talking about. After, for example, the pipe is installed in year, say we installed 2000. 2000, the thickness is 0.5 inch. We are taking here 2000 reading. So I am taking reading next to 2000, say 5 or 2005, I am taking reading. Now the thickness become 0.480 inch. Just I am giving some imaginary reading. 2010, I have a reading, say 0.470 inch. 2015, I have a reading, say 440 inch. And 2020, I have a reading 0.410 inch. Just I am writing random. So the last when we took the reading 2020, this reading is called as a T actual. The latest reading, it may be 1 year before or 2 years before, whenever it is there. Last reading considered as a T actual. Before that reading is called as a T previous. First, you should understand the terminology. Initial means first reading. Actual means last reading. Previous reading means a T previous. If you know this thing, then based on these three, we can do two calculations. What is the long-term percentage? What is the short-term percentage? So formula for long-term percentage. Percent rate, or we will call it shortly as a LT is equal to T initial minus T actual divided by number of years. So number of years between these two. So what is our first reading in here? 0.5 inch. What is the last reading? 410. How many years it is in service? 20 years. It is from 2000 to 2020. If you calculate it, 0.5 minus 0.41 divided by 20. So answer you will get 0.0045 inch per year. This is the percent rate. Huh? Yeah, because we started in 2000 first reading. After 20 years, we are taking readings. Oh, that is 20, not 2020. Okay. 20. 0.005 inch per year. Is it okay? Now, there is another correction rate is called as a short-term correction rate. Formula short-term means recently, T previous minus T actual divided by number of years. So T previous is 0.440 minus 0.410 divided by 5 years. So this is 0.006 inch per year. So we have two correction rate. Now, which correction rate I have to take it? Code does not say which one you have to use. Code says it will be decided by the inspector. But the general concept is you have to always take the higher portion rate. So which one is the higher portion rate? Short term. So this is the one we have to take it. If I have one more information, what is the minimum required thickness? T minimum, I can do two more calculations. Okay. So please just write this, then we'll go to the next page. Completed? Okay. Now, so if you have a set of data, you can calculate a long term and a short term. Suppose if you have only two readings, both are same. Suppose I have only 2000 and 2005 reading, then long term, short term, both are same. There is no long term, no short term. Both are short term only actually. Okay. Now, if you know, if you have some additional data, for example, T minimum, say T minimum, say I am putting T minimum 0.3 inch. What is T minimum? Is the minimum required thickness. It is same as a design thickness. That Barlow formula or TPDSC, that is the formula what you are calculating. So this is the T minimum. If you know T minimum, you can do two more calculations. What are the calculations you have to see? First, I will serial number 3. What was the original corrosion allowance? So what is the original corrosion formula is T initial minus T minimum, or we will call it as a T required. Yes, T minimum is a 653 language. Okay, T required. We'll change here also. So T required means minimum required thickness. Okay. So what was the original? Original. What is the initial thickness? 0.5. What is the minimum required thickness? 0.3. So 0.5 minus 0.3. That is equal to 0.5 minus 0.3, 0.2 inch. That was originally corrosion allowance. Now, next one is, what is the remaining corrosion allowance? This is important. Remaining corrosion allowance, we call it as a RCA. RCA formula is, what is the latest thickness? What is you call it as a latest thickness? T actual and T required. So what is the actual thickness now? 0.410 minus 0.3. That is equal to 0.11 inch. Now the third one is very important. What is the remaining life? So how many years the pipe can be serviced for another how many years? Formula is RCA divided by CR. CR means corrosion rate. RCA is the remaining corrosion. So what is the remaining corrosion allowance? 0.110 divided by, we can use both the corrosion rate. I told you 4 doesn't, so but which one is the higher one corrosion rate? 0.006. So 0.006. Please remember, this is not mandatory. Suppose code says, what is the remaining life based on the long-term corrosion rate? We have to use only long-term. Generally, it is given, then we have to use the higher corrosion rate. So answer is 0.11 divided by 0.006. So you'll get 18.3 years. So this pipe can be in service for another 18 years. If you round it, always round lower side. Remaining life, even if it is 18.9, 19 is not correct answer. 18 is only correct answer. Remaining life. Based on the remaining life only, when you are going to the next inspection. If you know the remaining life, see, these all are linked actually. So if you know the remaining life, next thickness measurement. Measurement is lesser of half of the remaining life, or table 1. So 570, there is a table 1 is given because it depends on the service class actually. I will explain later service class, just to write it. This is the way 570 works, the calculation. So I write already 7. There will be around 10 to 15 questions based on this. They will not ask all. Each question they will ask either short-term portion rate or long-term portion rate. They will remaining life or remaining portion allowance. So these are linked. So please write this. Then we will go some twist also will be there. Not every question will be straightforward. சொல்லுங்க என்ன டவுட் கொடுத்துருவாங்க. Sometimes if it is open book you have to calculate using the Barlow form. Here required if they ask you to calculate there is a open book question. If they already given in the question then it is a closed book question. You have to remember these formulas. These are closed book questions. These are not big formulas. Yes, you should know which one you have to minus with. But this one we will refer doing the table for this one. No, equal. Okay. Right. Now I will give you the data. Let me check how much you understand this. Visiting sir. Okay. So I am giving the year and the thickness. So 2006, the thickness was 0.4 inch. 2012, the thickness was 0.380 inch. 2018, the thickness was 0.340 inch. T required is equal to 0.25 inch. So you have to calculate 1, what is the long-term correction rate, 2, what is the short-term correction rate, 3, remaining life based on long-term, LT, long-term correction rate, calculate this. Then 4, what is the remaining correction allowance? Calculate all this. So LT 0. Per year. So we have to, how we have to calculate the LT? 0.4 minus 0.340 divided by 12. Okay. 12 that 12. Now short term 0.38 minus 0.340 divided by 6 years. What is the answer? 0. No. Either this should be wrong or this should be wrong. 005 varade. 1 minute, 1 minute. Let me check. No problem. 0.4 minus. No, you may be right. No problem. Divided by. Okay, correct. Second one 0.38 minus divided by 6. Okay, 0.661. Okay. And what is the remaining life? 18. 18 years. So what is RCA? So remaining correspondence formula 0.340 minus 0.250, 0.25, 0.09 inch. Okay. See, you have any doubts in this, please ask. Sometimes there may be a small twist. Okay. So what type of twist? For example, first one, again, I will give you the data. So 2000 year thickness. See, I have a data like this. No need. Okay. No need to calculate. I will explain it. So what is the long-term portion rate formula? So which values you have to this one? 0.5 minus 0.40 divided by 12 years. Suppose they give exam question like this. The service is changed in 2014. Then that will be become the initial value. This is the first twist. Sometimes they will ask, so they it is like a story. The question will not be very simple. The piping was installed in 2010 and the initial thickness was 0.5 inch. After 4 years, the thickness was 0.476. In 2014, the service is changed. After 4 years, in 2018, thickness was 0.44. Like that, then what is the long-term portion rate? The question will be like this. So long-term, you should not use the first reading. So T initial, the definition is, see, this is the definition for T initial. T initial equal to first reading or after service change first reading. First reading. So when service change, the initial will change. So long-term portion will be affected. Short-term portion rate will not affected by this. In a short-term only this. There may be one more twist. Instead of giving particularly months, they can give month and year. Okay, so I will just write this. For example, I am writing here, say May 10, 2010. This one is June 25, 2014. This is December 5 2018. This is takes us a March 25 2022. So I will explain how to do this. Generally, we will round the month. So June 10 means up to 15, we will take the first. If it is more than 15, you will take the entire month. Month we have to convert into year. How you will convert the month into year? Divided by 12. For year, how many months we have? Divided by 12. So now, based on this information, just to calculate all LT and ST for this. That's all. What is the long-term correction rate for this data and the short-term correction rate for this data? So long-term, again, I will repeat, you will not take this reading. You will take only this reading because service is changed. You should know how to convert the month into year. Calculate pannunga. Month you have to calculate it. How many months? You have to count it and convert it. Try this. So, okay, what is the long-term correction rate formula? 0.407 minus 0.4. Now, how to calculate it? See, June 25 means I told June is already completed. So, we will not consider June. So, left out is July, August, September, October, November, December. So, 6 months here. Okay, then 2015 is finished. 15, 16, 17, 18, 19, 20, 21. 7 years. 22 we have March 25 means 3 months. So 6 plus 3, 9. So 7 years, 3 by 12. This is the way you have to calculate. So 3 by 12, if you take 3 divided by 12, so 0.25. So, okay, 0.47 minus 0.4 divided by 7.25. So this will be 0.0096 per year. Now, what is the short-term formula? I will write here because there is no space. 0.44 minus 0.4 divided by, here December 5 means December not yet started. So we have 1 month December. Then 19, 20, 21, 3 years, another 3 months. So 3 years, 4 by 12. Here only 1 month we have. So 3 by 4 years, so 0.4 minus 0.4 divided by 3.4 by 12, 2.1. 4 divided by 12, what is the value? 0.33. Okay. 0.44 minus 0.4 divided by 3.33. It will be 3.33. So 0.012. Okay, that's all for today.